Hello, everybody. As you saw me in the opening messages, my name is Leah Den Hartog. I am the editor of Plumbing and HVAC magazine. I'm here to introduce our next session of the day. It'll be on ductless systems and heat pumps. The presentation will be conducted by Michael Schaber. He's the HVACR Technical Service Advisor at Wolseley. And then we also have Joey Robertson. He is the category HVACR Sales Specialist. So thank you both today for taking some time out to speak on this topic. We're having some stragglers come over, but I'm sure we'll have more and more people join in as the last session has now ended. So kick it off. If anybody has any questions during today's session, please ask during the presentation. We will be pausing for any questions during it to make sure that we can address them right away. So take it away, gentlemen.
Okay, welcome. Glad to be here today to share a few thoughts with you. So like she said, if you have any questions, just bring them forth. So here's our agenda. What is a heat pump? How to choose a heat pump? How to size a heat pump? Maintenance of them. Ductless, what is it? Ductless applications. Ductless inverter principles and operation. And the types, single zone, multi-zone. Then a bit on installations and questions and answers. So I'm going to get Michael to introduce himself and tell us a little bit about himself.
Hey, good morning, everyone, and thank you for your time and consideration and joining us on our heat pump presentation today. My name is Michael Schaber. I am a HVAC Technical Service Advisor for Alberta here at Wolseley. My experience in the field is that I've been a HVAC technician for the last 30 years before I retired. I hold tickets in sheet metal, roofing, and gas fitter A. And so after I retired, I joined the Wolseley team, and now my job is to help those who buy HVAC equipment when they need technical help, installation, troubleshooting. That's what I'm here for. So I'm really happy to be a part of this presentation today, and thank you once again for joining us.
Thank you, Michael. And I'm Joey Robertson. I'm the category HVACR sales specialist for the Atlantic Canada for Wolseley. And I am out of Moncton, New Brunswick. Experience, I was a small business owner for 24 plus years, repairing small commercial refrigeration units, mini splits, appliances, and I've now been with Wolseley for 11 years. So question is, what is a heat pump? A heat pump is a device that transfers sensible heat from one location to another rather than generating it. So it just moves heat from one part to another, basically. So there's different forms of heat pumps. There's air to air. That's what we're going to be concentrating on most today because that's the most popular. There's the geothermal, which is the most efficient, but unfortunately it's also the most expensive to install. You have a water source heat pump, an air to water, and a VRF. And over to the right, we have a ductless system, the components. So basically you have your indoor units, your controller, and your outdoor units. And your indoor unit will come in many different forms depending on what you choose for the outdoor. So parts of a heat pump. The heat pump has different modes, with air conditioning and heating being the main two. During the air conditioning mode, the refrigerant will absorb the heat from inside the house and reject it to the outdoors through the outdoor coil. Moisture is also removed from the interior and drains by gravity, or you have a condensate pump is used. During the heating mode, the circuit reverses and does the opposite, where the heat is transferred from the outdoors and rejected to the inside coil to the interior of the house. Heat pumps come in many different combinations, from standard single units, 1-to-1, one unit, one indoor, one outdoor, multi-units with multiple indoor heads, side discharge for central heat pumps that can be paired with an air handler, cased or uncased coil, and combined with an electric, gas, or oil furnace. They also come as standard unitary units with one outdoor unit with an air handler inside. Heat pumps come from many sizes, from 6K to 60K, depending on whether it's a mini split or a central unit, and it can be installed in various ways. Now, the parts of a heat pump, you have an indoor and an outdoor unit. You have a coil in the outdoor and indoor units where the heat is absorbed by the refrigerant and then rejected from depending on what mode is selected. Control board, which is with the inverter, which is the brains of the operation. The inverter controls the speed of the compressor, which depends on the demand of the room or the system at that time. Reversing valve does exactly as it sounds, reverses the flow of refrigerant when the mode is changed from AC to heating or vice versa. You have fan motors on the indoor and outdoor to drive the air through the coils. The speed of these will also be affected by the local demand or loaded demand. Compressor is what pumps the refrigerant through the line set and coils. It also compresses the refrigerant so the heat can be rejected through the coils. Expansion valves. One of the most commonly used today is the electronic expansion valve, better known as EEV, and some still use a TXV, thermal expansion. This controls the flow of refrigerant throughout the system, and it opens and closes again according to the demand. Then you have thermistors on both the indoor and outdoor units, which change in value. The main control board knows what to do with the value that it reads. Now, how do they work? Well, you've got a single zone that will go one with one, and you've got a small pipe, small opening, little impact as far as installation goes. Multi-zone has one outdoor compressor, can power up to 5 indoor units. Each indoor unit is controlled by a wireless remote, and the outdoor unit rated down to -30 in this particular case. But you got to remember that even though it says it's rated for -30, it's not producing 100% of its output. So you got to check the specs of the unit to see what the true output is at any given temperature. So outdoor units, you got a single zone. So on some of the units, one single zone will only pair with a high wall. And then on other single zones, they will pair with any of the units you see on the right-hand side. So it's but it's only 1-to-1. So the outdoor unit will go with a console, for example, or a ceiling cassette by itself, kind of thing. So you get to pick and choose what you want to install with it. The multi-zone, it's got, again, depending on the brand and the make, you can have 5 to 8 indoor units with 1 outdoor unit. The largest one, as you can see in the picture, has 2 fans, whereas the smaller one is just a regular unit with just the 1. This here will depict your central system. Up here you have on the right-hand side a C5H3V, for example. That's your outdoor unit. And you can pair that with your gas furnace and your case coil down in the right-hand corner. And if you so desire, you can pair the outdoor unit with an air handler with an electric backup. Again, it depends on your situation, where you are, how expensive gas is, how expensive electric is. So it all depends on where you live and on those situations. And then you will have a control that will control them. It can either be a communicating control, which will basically, when you go for setup, the contractor will have a much easier time because it'll help them out. It'll recognize the different models as you go. Or you can even zone the system as well and have different zones throughout your house. Criteria for the right heat pump. When choosing a heat pump, you should consider the following. What is your budget? Is there any government rebates available? What region or climate will be installed in? Do you need ducted or ductless? Single units better, or should I have a multi-unit? Do you want Wi-Fi? Trusted name that'll be around for years to come so that you'll be able to get it serviced. And also a trusted installer that will be around to look after the service when needed, because we see a lot of people that come and go over the years. What kind of warranty does it have? Is the availability of parts? If it breaks down in 5 years, are you going to be able to get it fixed? Very important too, look for the coefficient of performance. It's called COP, the ratio between the rate at which the heat pump transfers thermal energy in kilowatts and the amount of electrical power required to do the pumping in kilowatts. For example, if a heat pump uses 1 kilowatt of electrical energy to transfer 3 kilowatts of heat, the COP would be 3. The higher the number at the colder temperature, the better the unit is. And of course, the better the unit is, the more you're going to pay for it as well. But you'll get your money back in the long run, just in electrical savings. HSPF 2, that's another, it's heating seasonal performance factor. It's another thing to look for. It's a metric that measures the efficiency of heat pumps during the heating season, and the higher rating indicating greater efficiency. Does your unit have a baseband heater? Very important when you're in cold climates, as it prevents ice from forming in the baseband and damaging your coil. And then you have some real issues. Remember, ductless heat pumps are not meant to be your primary source of heat. You should always have an alternative source in case of failure, or the unit can just not produce enough heat at extreme cold temperatures. It's the size of heat pump. This should be done by a qualified professional that should do what is called a heat loss, heat gain calculation on your home, so that you know the proper size unit to install. This is important because oversizing or undersizing can create issues. In heat pump case, bigger is not better. With the proper sizing and correct installation, your heat pump should give you many years of service. Maintenance, you will need to clean the filter on a regular basis. The time depends on whether you have a ductless unit or a central unit, and it also makes a difference if you have animals or if you have a home that's in a high traffic area. Another preventive measure is to use the dry coil feature on your mini split after using AC mode to stop the forming of mold and mildew. If your unit doesn't have this, put it on the fan only modes and let it run for a period of time till the coil dries before shutting it off. That'll basically stop it from forming mold and mildew, and you'll be getting a smell out of your head as it runs if you do so. Have the unit cleaned by a contractor to remove any mold or mildew buildup. And if in the winter, keep the snow shoveled away from the outdoor unit. In the fall, there's lots of leaves flying around, so make sure your outdoor coil is kept clean, because sometimes they'll suck them in the back and they'll stick to your coil and cause a restriction in your airflow. Ductless air conditioner or heat pump, also known as a mini split, operates without the need for ductwork. Ductless systems utilize inverter compressor technology, allowing each unit, both indoor and outdoor unit, to continuously adjust heating and cooling capacities to best match a room's current condition. Inverter technology can control with less fluctuation and less power consumption. The indoor blower can modulate continuously for better comfort control and cost savings. As targeted solutions for application of heat-cooled technology, provides better and more complete control targeting areas with uneven temperatures. Ductless means less labor, material, and potential less time installing. In summary, ductless systems provide efficiency and targeted climate control, making them a great solution for homes without existing ducts or for room-specific cooling and heating needs. Where would a ductless system be beneficial? These are just some examples, like a sunroom, for example, a bonus room, a basement. You can install it in numerous places, and you'll be very happy that you did so, both on the AC side and the heat side. Looking for a place to put your high wall. Very important you place it in the proper place to get it to work properly and get the performance that you want out of it. Your electrical power, I mean, you're going to have to drill a hole through the wall too, so make sure you know where you want to get it. Sizing, connection, refrigerant piping's all got to be brought through that hole. Condensate handling, is it on an inside wall? Is it on an outside wall? Much easier if it's on an outside wall, then you can just run your condensate out the back and it will drain by gravity. Otherwise, you got to put a pump in to get that water to go outside or go down in the basement into a drain somewhere. Service and maintenance, make sure you'll be able to get it apart. Do you have access to it? You know, like when the guy comes to fix it, can he get it apart to fix it? It's jammed up against the side of the wall. You may not get the cover off like you need to, and something might have to be broken to just get it apart to do service. So important you have the room on the sides and the top, just so it'll work properly. Airthrow, again, in front of it, you've got to have enough room that you can get lots of air flowing out there and not coming back to the unit. So it's reading the temperature of the air coming back right away. It's got to be able to go out and penetrate that room.
I'm going to interrupt you for a second. We got our first question of today's presentation. So Juan is asking, is there a minimum temperature where the HP stats to loose efficiency and alternative heat source need to be used?
Say that again. Sorry, I missed part of that.
That's okay, no worries. Is there a minimum temperature where the heat pump starts to lose efficiency and alternative heat source needs to be used?
It really depends on what unit you select. Like right now, there's units that will go down to minus 35. I think there's even one to minus 40. So they all lose efficiency. Some of them at minus 15, and some of them that we sell at minus 35, they're 70%. Some of them at minus 25, they're 100% of the value of it. So if it's a 12,000, you get 12,000 out of it. So it really depends on what you choose, but there is a point there that they all lose efficiencies. Yes.
Is there a resource for the installer to reference back to determine what that specific unit's the low it starts to lose efficiency? It was operating.
Usually on the submittals, the manufacturers provide you submittals, or they'll provide you with a temperature curve. And that'll tell you what the efficiencies are at certain temperatures.
Okay. All right. Thank you.
Okay.
All right. We're good to go.
All right. I think I finished that one basically. Indoor insulation, again, we'll go over this because it's important where you put it. Good air circulation. One thing about refrigeration of any kind, you need airflow, airflow, airflow. And you need to have good airflow around your mini split. And it doesn't matter what type of head it is, whether it's a high wall or any other kind that you select, you've got to have good airflow. Drainage, again, you want that water to go outside and onto the ground, not through your wall or through your floor. Noise from the unit, so it won't disturb others. You put it in a bedroom, sometimes they'll make certain noises that irritate people when they're sleeping. Make sure it's solid on the wall so there's no vibration, and make sure that it's 3.28 feet from other electrical devices, TV, radio, computer. Sometimes people will install them over top of a TV, but not a real great idea because you could get electrical interference. But if the unit ever leaks, you may be looking for a TV as well. And it'll just run down inside and blow it up. So do not install in the following locations: near any source of heat, steam, or combustible gas, near flammable items such as curtains or clothing, any obstacles that'll block the air circulation, near the doorway, in a location subject to direct sunlight. The reason the doorway or even a window sometimes, because a lot of these mini splits have the thermistor that reads the temperature at the head. So if you get a draft on that head, it'll throw the temperature off and it'll think you need a lot more heat than you actually do because of the draft. Outdoor units, again, clearances, make sure it's far enough away from the building so it has airflow, airflow, airflow. Your piping distances, make sure of your piping distances because manufacturers give you how many feet you can go without having to add refrigerant to the unit. So if you go by that, you've got to add refrigerant to make sure you've got enough in the system. And normal install run between 8 and 15 feet. That way you don't have to add refrigerant and you keep the noise outside where it belongs. You don't get as much transfer of noise that way. Electrical run, basically how far do you want to run your power from your main boards or from your main panel to the units? And do you have room in your panel, first of all, too, before you buy one? You got to make sure you have enough room in there to be able to accommodate the units. Disconnection, that's the little box you see in the picture to the right of the mini split there in the picture on the right-hand side. And that's there so that when the technician goes to do work on it, he can pull the power there and then he knows the power's off so he doesn't get injured. Now, the next thing is, do you want to use brackets? Do you want to use a pad and stand? How do you want to install that outside? A lot of times here it'll be right on the ground on a pad with a stand, but you can also use wall brackets and install it on a wall. The only thing I would say is you got to be careful when you install it on a wooden wall because you'll get noise transfer inside the house. Winds, again, with the winds, you may get a lot of dust and dirt and debris blowing onto the back of the unit, which all that sticks on there and creates problems with your airflow. And snow accumulations, make sure it's above the snow line and you got the proper clearance there. And if there is snow, make sure you clean around it so that it can breathe again and get lots of airflow. Noise. One of the things about noise is, or what I find is, a lot of people will install them outside of bedrooms. Well, if you're a light sleeper in the middle of the winter when it's January, that machine's going to make noise. Doesn't matter how good a unit is, it's going to be pumping away pretty hard and it's going to make noise. So if you want to sleep at night, don't install it outside your bedroom window. The other part is keep it away from dryer exhaust vents because you got all that hot air, moisture, and lint going out. And again, could be all stuck on the back of the unit, creating an airflow issue. So now we go to controllers. You've got two kinds of controllers. A mini split can use a remote wireless, or it can also be controlled by a wired wall control. Again, make sure you put it in the right place so that it reads the temperature properly. Now, there is some wireless remotes. Basically, all they do, most of them, is you set the temperature and it has nothing else to do with the operation of the machine. The odd one will have what they call follow me. And that one actually reads the temperature at the thermostat where you place the wireless, remote. You can also go to these websites, the Enercan websites and the NEEP websites, and it'll tell you if they're cold climates, if they're Energy Star, how good they are. Very good. And if there's any rebates and kind of stuff like that, if they're available for that. So very good resources to go there as well.
All right. Thanks, Joey. Let me get set up here.
Okay. We shut this off here. There, is mine gone? There you go. Sorry.
Okay. How's my sound, and can everybody see me as in full screen? All right, we're going to talk about continue on with what Joey was talking about we're going to expand upon ductless inverter principles and operations. What is inverter technology? Basically, inverter technology for heat pumps uses variable speed systems to provide more efficient cooling and heating. What this entails is that it's going to constantly adjust its power output based upon your targeted needs. This maintains a constant temperature while using less energy than traditional furnaces and air conditioners. In summary, inverter compressor technology allows HVAC systems to constantly adjust the amount of cooling or heating it provides. Now, in HVAC terms, you may call this modulation, but let me give you a real-world example. Inverter technology is like an automatic transmission in a car. When you put your foot on the gas pedal, it's asking for more demand, so the engine RPMs rev up and it gives more power to supply that you're asking for. When you take your foot off the pedal, it will ramp back down to the idle and it will just slow down. So same thing with inverter technology. Depending upon the set point, the needs, and the sensors in the room and the demand that is needed, your outdoor unit is constantly adjusting the flow of refrigerant to provide the most economical and efficient way to get the heat to or from the area you are controlling.
Michael, I'm going to interrupt you for just 1 second. We have a question.
Sure.
So Theodore asks, you mentioned earlier that some heat pumps are rated down to -35 Celsius. Can you share some of the brands that operate down to this temperature, and are they available in Canada?
Okay, that's a great question. Thank you very much for that. First of all, there are many brands that offer what we would call heat pumps with what we call normal capacity down to -20 Celsius. There are what we call other brands that have high heat models that will go down to -30 Celsius. Actually, a brand that will go down to -40 Celsius. The brand for -40, I believe, is Mitsubishi. And then the other brands that will go down from -20 to -35, whether it's ICP, Goodman, LG, as you've heard speakers before us. I believe that most major brands, they are all offered in Canada, and they come with normal heat capacity units. And then there are what they call high heat capacity units that are down, that go past -20. Just have to check the brand specific for their capacity. But that's a great question. Thank you for asking that.
Thanks, Michael.
Now, the sensors that are commonly associated with inverter technology, which most major brand manufacturers for heat pumps today, they encompass 5 different kinds of sensors. We have a return air sensor. We have a refrigerant pipe sensor. We have an outdoor air sensor, and we have a heat exchanger sensor and a discharge sensor. All of these sensors they are in essence sending information to the board of the outdoor unit, and the unit is using its algorithm to make that unit run as efficiently and economically as it can, depending upon demand and set point. Now, as Joey was talking about before, installations, it's critical that you know the brand and know the clearances and the limitations that it has on installation. So, for example, with this high wall unit, I want everybody to know that there are 4 possible exit locations that you can do for condensate and line set on your high wall head unit. You can do a left-hand side location, exit location. You can do a right-hand side exit location. You can do a left hand out of the rear, so you will not see it come out the side of the unit at all. And then you can do a right rear exit location. Now, when you are making the hole, one thing that I have noticed is was my experience, that do not make just the hole go straight through the wall. Give it a little bit of an angle down. Half inch should suffice. What that does is it helps with if you are using just the condensate to go into, to flow out the back, or to flow into let's say a hard pipe inside a wall, you just want to try and maintain a positive slope down or away from the unit, so that gravity will do its job and it will take the condensate away from the indoor head unit. Now, as Joey was talking about before, and as the presenters from LG were talking about in the previous session, mounting the plate to the wall is key. We want to make sure, first and foremost, that it is perfectly level. If we try and aid the unit to slope to the left or to the right, it's not really aesthetically pleasing, and then the customer may come back to us and ask to adjust it. So please get it like a 2 or 3 foot level, put it on the top of your mounting plate, and then mark your holes, drill them out, and anchor that back plate securely. A good looking level or plumb insulation makes for a happy customer. As I said there, use pencil for holes. If it's brick, we want to use the appropriate bits and holding anchor material for the screws. And as I said, make sure it is plumb, make sure it is level. At this point, there's a famous saying in the HVAC industry where we go measure twice, cut once. With the installations of mini splits, I would say make sure you measure with your level twice, and then you start drilling your anchors in. Okay, condensate drain tubing. Condensate drain tubing, by default, the drain hose is usually to the left-hand side of the unit when you face the unit head on. However, it can be attached to the right. And I believe that most manufacturers today, if you look down at the bottom right-hand picture and the bottom left-hand picture, you can see that there is a plug so that you can actually take the condensate portion that is provided in the high wall unit, and you can shift it from the left side or the right side depending upon your needs. The most critical thing here is to make sure that you put the plug in back in the unused port, because if you don't, you will have condensate coming out of there. So it's key to make sure you put it back in there. It's friction fit. It will come out with normal hand pressure, and it does have a rubber O-ring to seal so that it won't come out. And just to leave everybody here, condensate from high wall units is under no pressure at all. It is strictly falling off the coil into a pan, being collected, and once it collects enough, it will either exit out of the left port if that's where it's been attached, or it will exit out the right port. But it is under no pressure whatsoever. As you can see here, 4 things that we want to make sure. Number 1, that we have a proper condensate drain coming out of the back, no kinks, no rises, that it's not put into a water or a pump where the end is submerged. We want to keep it so that it does not get waterlocked, okay? So that the gravity will do its job and it will keep flowing out. Let's look at the outside installation. As Joey was talking about, I think the most critical thing for outdoor installations is to make sure that we get the heat pump off the ground. Unless you're in a temperate area of Canada, which I'm not really familiar that there are, we have snow load in almost every region of Canada. And since we have condensate forming outside, we want to make sure that this condensate has a way to escape the unit. In the slide coming down, I'm going to show you, but we don't want any portion of the outdoor unit to be encased in ice, because what ice does is it contracts and expands. It will damage aluminum fins. It will pop copper, and it could potentially stop the blades from the fan motor from actually spinning. So, number one here, convenient for installs and not exposed to strong winds. The reason why strong winds are a factor in determining our outside potential spots for location is that a strong wind could prevent the heat exchange during defrost cycles, or you have a heating or cooling cycle. And what I mean by that is, let's say that you put this on north side or a west facing wall where the prevailing winds usually come up. That's what they are in Alberta here. And you have a very strong wind and you put it on defrost, and the motor is trying to pull the air through the coil. Well, it actually wouldn't be able to, because it's being met with a very strong wind in the opposite direction, which is trying to push the air back through the coil, and you're trying to pull air through the coil through the back. They meet in the middle. It goes nowhere. You have no heat transfer. You have no cool transfer. It's just not a good situation. So if you don't have an ideal location, I would recommend some sort of barrier, whether it's lattice or some sort of metal grating. You want to make sure that strong wind is not going to affect the performance of your outdoor units. Now, I know that strong winds won't sit there and turn an outdoor blade assembly on its own. If that is happening, we have another problem besides the strong wind. There's something wrong with our fan motor itself. But generally, we want to protect the outdoor unit from direct strong winds, okay? We want to make sure we have the appropriate clearances from snow loads. As Joey said before, 15 to 18 inches is good. Get it on a stand, and whether you put a pad on the stand or whether you do wall brackets and you put a pad on the wall brackets, get it off the ground. We want the condensate to get away from the unit. We do not want any kind of ice buildup in these outdoor units at all. Okay? So, and just take a look at your installation manual. They will talk about, if you do have, as I mentioned in the note there, do not install the indoor or outdoor unit in locations where you have special environmental conditions. And what I mean by environmental conditions would be, for example, you have a lake property and your house is off the lake. Sometimes you can have lake effect snow, you can have lake effect wind. It's critical that we try to keep the outdoor unit from those special environmental conditions so that they can run as efficiently and effectively and economically as possible once they have been installed. All right, the do's and don'ts of installations. Okay, let's look at the do's. Let's maintain minimum clearances. So for the outdoor unit, depending upon your brand, you want to try and maintain that you have enough airflow that comes from the air inlet as marked by E. We want to make sure that we have adequate air coming in the back to go over our coil, to be pulled through by our fan so that we can have the proper exchange. We don't want to make the mistake putting the discharge on the inside of the wall. Personal experience, I have done this in my 30 years, was you do it once, you'll never do it again. And most units are clearly marked on what side is the inlet and what side is the outlet. Wall mount an outdoor unit above an occupied area where water drippage may be problematic. So In other words, if you are putting it on the side of the house and it's right above a sidewalk, you might want to get that either into another location, or you may want to use some sort of clear vinyl tubing or hard tubing or something to get the condensate from just dropping straight onto a secondary access sidewalk, so that there's no ice forming and there's no slipping or hazard for anybody walking on the sidewalk. We want to position the unit so that the prevailing wind will not cause the fan blades to freewheel. And then the final last one, multiple outdoor units in a manner where the discharge from one unit will not affect the other. So let's take a look at that. As you see in this picture here, if you are installing these in a multiple dwelling building, there are some considerations that we have to look at for clearances. Number one, the discharge side, we want to keep at least 59 inches or 5 feet away from the facing of the other unit across from it. And so what I mean by that is, if you are doing a cooling cycle and the hot air is being discharged from, let's say, the middle row unit, and it's pointing to the third row on the north there, we don't want that heat to inadvertently influence the temperature sensors that are in that unit. So we want to try and maintain minimum clearances when we're doing multiple units. As the LG person says before me in his presentations, we want to try and maintain proper clearances back to back and side to side. Now, it says here in some brand manufacturers that if you were to put them side by side, it says 10 inches would be adequate for minimum clearance, but we're actually looking for about 24 inches of clearance. So to a technician like myself, if there was ever a problem with one of these 9 units in the display, we want to make sure that they can A, take panels off, B, that they can get access to all the sides of the outdoor unit, and that they are not going to inadvertently affect another unit that they are crawling around and working on. Okay, so it is key to making sure that clearances, at least the minimums, are done, but there are good trade practices where we want to try and keep 5 feet from the facings, 24 inches from the sides, and 24 inches from back to back, so that they do not have to rob air from one other unit to get air for themselves. Okay, so minimum clearances must be followed. As I was talking to you before, this is an example of your condensate port at the base pan of your outdoor heat pump. Most manufacturers have a heater in the base pan so that the condensate that is in there will never ice up. And what you can see when you look at the bottom of the outdoor units is you can see that the unit has been specially designed to flow condensate when it collects to the port. It's not flat in there. It's angled and it's made to flow to this. And so that way, the condensate, when it's rolling off, whether it's in the heating or cooling mode, it will get away from this unit and no ice will build up in the bottom at all. Make sure that when you are doing maintenance on these units after they've been installed, that you have your service technician clean out debris, dirt, leaves, needles, pine cones, all that stuff, so that nothing can clog that drain up. Because it can be anywhere from a 3/8 to a 1/2 inch opening, and it doesn't take much from vegetation matter to actually clog that hole up. So annual maintenance is important on this, but it's also important to make sure that you have this serviced. Okay, let's look at refrigerant piping. When I was in school doing training on compression fittings, there was an interesting test our teacher did in the class, and he wants to find out how good we are at tightening, doing torquing, because we all know that there are torque wrench settings in the manual, and he wanted to know if we could do it. Now, many of us guys and girls, we're very strong, and we think that we don't need to worry about what the foot pounds are, the newtons are, and we just tighten to what we think and we're close enough. We found out that in 80% of the students who did the freehand tightening, that they were actually less torque than they were required in the manual. So there are many torque wrenches out there, digital, that are attached to adjustable wrenches that you can use to make sure that you get to the appropriate tightening torque. And that way you will know for sure with your installation that you may potentially not have a leak. Of course, we want to make sure that our flare is not broken, not cracked, not torn, and that we're not using any nylock or any kind of seal in there, because that's going to more create a seal than to actually help ensure that the compression is what actually is doing the sealing. So we want to make sure that our torques are to the appropriate install manual for your brand. That way you know for certain. Let's talk about the evacuation during installation. All brands in their manual will talk about their evacuation process. Most will talk about deep vacuuming or triple vacuuming. Vacuuming is an essential part of the HVAC system because it removes all presence of moisture in the line set. We put nitrogen in there to dry out the line for the nitrogen molecule to bond to the water. It then becomes an inert gas. We then remove almost all of the nitrogen down about 2 psi. Then we start doing our evacuation. And the evacuation method that is most preferred for most brands is what we call the triple evac method. The triple evac method consists of this. We are evacuating, first of all, down to 1,500 microns. And then once we reached 1,500 microns, we will stop the evac process, pressure the line set back up to 0, because when we've evacuated, it will go below 0. Once it's at 0, we are going to stop the nitrogen in, and we are going to restart the evac and go down now to 1,000 microns. Once we've reached 1,000 microns, we are going to stop the vacuum pump, and we are going to inject nitrogen again back up to 0 psi gauge pressure. Then once we reach 0, we are going to once again turn the evac pump back on, go down to 500 microns. Once it reaches 500 microns, we are now going to perform a hold test. This hold test we want to make sure that the pressure test stays around 500 microns. If it holds for 30 minutes, we have made sure that the unit is in a complete vacuum and that we are good to go to start commissioning and start up the unit. Sorry, I missed this one point here at the top there. It is important that when you are doing a nitrogen pressure test, that you are testing the line set and the joints for 500 psi for an hour. This is a good gauge because working pressure, both in cold and heating, can get upwards of 425 to 450. So we're going to do 500 because this line set and the joints in the outdoor unit and the indoor unit are measured for over 600 to 800 psi. So 500 is not in any way, shape, or form going to hurt your joints, your service ports, or your compression connections or your line set. Okay? Let's talk about wiring. All wiring must be sized to the National Electrical Code or the Canadian Electrical Code, or if your authority having jurisdiction has some special codes, please make sure they adhere to it. All of the manufacturers have the MCA or the minimum circuit amps or the MOCP, the maximum overcurrent protection, clearly on their rating table or rating plate, which is on the outdoor unit or in the manual, so that you can be sure that you are putting the right one in. We want to make sure that the cable or the wire that is coming from our electrical box, that it is the right field supplied power communication wire. Now, when I talk about that, we got a slide coming up here, but there is mini split cable, which is a 14-4 stranded and shielded wire for the outdoor to indoor unit connection. And then there are other RS 485 communication cables. There are other communication cables that are a 14-4 or 14-3, three of those being power connections and one of them being a communication connection. Always make sure you consult with your brand manual to make sure that you are doing the required size. Just so everybody knows, the lower the gauge goes, the thicker the wire gets. But after gauge 10, you now start going from solid core to stranded. Whereas as you get higher above 14, you now can start doing stranded. The big difference that I want to implore here to everybody is that we are not using a Lumex, which is a solid core, or a BX, which is a solid core, because once you break that solid core, you are not able to see if it is broken, and you could have performance and communication issues. Tools and equipment. Having good tools is key to a great install. A good vacuum pump is awesome. A hand or a manual flaring tool, cordless or a battery operated weigh scale, a micron gauge, good manifold gauge, proper hoses, whether you use a ratcheting type of bending set or a manual metal slinky type. Having good tools and good performing equipment is key to your installation. Now let's talk about line sets. Now, not all line sets are not made for all heat pump installations. As you can see there, I put down, you have your traditional AC line set, which consists of a Armorflex covered suction line and a bare exposed high pressure liquid line, whereas a ductless line usually already comes pre-fitted on both ends with compression fittings, fitting plugs so that the line sets will not be contaminated with dirt or water vapor. And they also have some form of Armorflex on covering both the suction and liquid line. Now, as I said there in the caption below, ductless line sets are always, and then I put an asterisk here, insulated. It does not matter what color the insulation is. What does matter is that the insulation is UV rated. And you will go to, it's been my service experience that I've gone to many ductless installations and they have not used the proper Armorflex if they ran line sets as bare copper and then put Armorflex on them afterwards, because you can see you go to the job site a year later and the Armorflex, which is not UV rated, is falling, crumbling, and basically dust in your hand when you touch it on the line set. So, as I said, please consult your brand manufacturer. There are some unitary or traditional 2-split heat pumps that do not require both line sets to be covered, only one. But in the ductless line set, we need both because both lines can become hot or cool depending upon the direction of flow that the refrigerant is going. The next thing I want to highlight here is that line set sizings are particular to the way that the ductless zoning is done. If you have a single zone, your line set is always sized according to the indoor unit. So if you have, for example, half-inch, quarter-inch line set connections on the indoor unit, you get a half-inch, quarter-inch line set, and you make your adjustments. If the outdoor unit is different, you make your adjustments at the outdoor unit, never at the indoor unit. And the reverse is for the multi-zone. We are always sizing our line sets according to the outdoor units. So depending upon the service port sizes, if they are a half-inch 3/8, you use half-inch 3/8 line sets all the way into all of your different head configurations, and then make the adjustments at the indoor head unit. As I was alluding to about wiring earlier before, please make sure we use the appropriate wiring, that it meets the electrical code or the local code in your area. As I said, these are just some forms that are not acceptable. And I have been to many job sites where, let's say, building owners or building contractors have put these units in and have run BX cable or Romex, and they wonder why their units don't work. Or when a service technician comes to start them up, they don't work. It's because they put the wrong electrical wire in. We want to make sure that we put the right conduit in there. We want to make sure that it's rated for our units and that it is the right size.
I'm going to interrupt you for a second just to let you know we have 2.5 minutes left.
Okay.
Do we have a quiz as part of this presentation at all?
No, we do not.
No? Okay. All right. Perfect. All right. Keep on going.
Okay. I'll try and make this quick here. Guys, these are some examples of great installations. Just want to make sure that everybody knows that, as I've alluded to before, and as was presented by Joey and by LG before, we want to get these units off the ground. A stand or wall mount. If you choose to cover the line sets, as the picture in the right with the line set cover, great. Try and keep these 3 feet away from dryers. Make sure that our outdoor disconnect is 3 feet above the grade, and this is just a specific to Alberta. Please consult your local code. They are looking for support for conduits or for your electrical conduit from the disconnect to the unit 12 inches below the conduit. And as I said, there are many options for line set covers out there. The 2 common most sizes are 3.5 inch and 4.5 inch. Just make sure you get the appropriate size. If you have more than one line set going in there, you might opt to go to the bigger size. And the line set covers can come in some different colors. I am familiar with white, brown, or an ivory cream color looking thing. Just makes it looks a lot better than seeing a whole bunch of spider webs of your ArmorFlex line set outside. As for that is my presentation. Once again, I want to thank everyone for attending. I thank you very much for your time and consideration, and I hope that you have yourself a great rest of your day.
Wonderful. And you're perfectly on time. You got 25 seconds. So I don't think we're going to have much time. Any more questions when we had our time during it? So you had your piece, and I've given lots of notifications to our attendees. So I just want to thank both you, Michael and Joey, for today's wonderful presentation. I for sure learned a lot. And everybody else that's still in this chat, make sure that you join in for our next session on To Buffer Tank or Not to Buffer Tank by Michael Riddler at Eden Energy. So thank you again.
Thank you, everyone. Thank you, Leah.
Thank you.